Well, it's been a few days since the textbook crashed on me while I was trying to make this lesson, so I'm just now getting back to part 2 of Module 7, Lesson 5, which covers Determine the Number of Solutions. A quick recap from me. You can have one solution to a problem, you can have no solutions to a problem, or you can have an infinite number of solutions to the problem. And to find out what those solutions are, we're going to have to take and simplify both sides of the equation and see what it ends up getting us. So for here, they've given us the equation that says that 8 times the difference of 4 and 2x minus 4 times the difference of 3 and 5x, equals 4 times the difference of 3 and 5x is equal to plus 4. I'm just screwing this all up as I read it, aren't I? What we're going to have to do is simplify everything on the left side of that equal sign and everything on the right side of the equal sign and see what happens. Now you can see on the left side of the equal sign, they said 8 times 4, that was 32, and 8 times 2x, that gave them 16x. On the right hand side, they said 4 times 3, that gave them 12. 4 times a negative 5x, that gave them a negative 20x. Now they're going to combine their like terms where they have the negative 20x plus 4x. The signs are different, so they found the difference, which gave them a negative 16x. Sign in front of the larger number goes in front of your answer. Now you can see right here that it's going to come out to be pretty, it's not going to be right, I don't think, because he has negative 16x on both sides. One of them shows a 32, the other one shows a 12. I'm thinking this isn't going to work out too well. To prove it, what they did is they took and added 16x to both sides. And by adding 16x to both sides, that ended up leaving them 32 was equal to 12. Now I'm going to ask you, is 32 equal to 12? No, it's not. And because 32 is never equal to 12, we can say that there are going to be no values that can substitute it in to make the equation true. Check it. The answer checks. And what else did they give us? Nothing of value there. The equation is not true. Now you take a minute and pause the video and you go on and work extra example number 2, which wants to know which of these equations have no solution. That means you got to simplify all 4 of them. Go for it. So how'd you do? Let's take a look at how I'm going to end up working these things. My first one is going to be 1/2 times the sum of 8a and 4 is equal to 2 times the sum of 2a and 1. When I simplify this one down, 1/2 times 8, 1/2 of 8, that's going to give me 4a, plus 1/2 of 4, that's going to give me 2, is equal to, on the right hand side, 2 times 2a, that's 4a, 2 times 1, that's going to give me 2. Now you notice that both sides of that are going to be equal or exactly the same. And since they're exactly the same, we can go ahead and say at this point, that one's going to be an identity. It's going to have an infinite number of solutions. But to prove it, we have to keep going. I'm going to subtract 4a from both sides. And when I do that, the 4a's are gone, leaving 2 is equal to 2, which is a true statement. That one has an infinite number of solutions. That's not what we're looking for. We're looking for problems that have no solution. Now I'm going to change my pen color and we're going to end up trying another one. So let's go for a green pen this time, and we're going to take 5 times the sum of c and 1 minus 12 is equal to 1/3 times the difference of 12c and 24. 5 times c plus 5 times 1 minus 12 is equal to 1/3 of 12c, well, 12 divided by 3, that's going to end up leaving me with 4c. 1/3 of 24, that's 24 divided by c, that's going to give me 8. Now I'm going to take and subtract 5, I'm combine these two like terms here, which means that 5 minus 12, that's going to give me a negative 7. So now I have 4c minus 8 still on the right. And now it's time for me to start isolating my variables. I'm going to do that by subtracting 4c from both sides. These c's zeroed out leave me with a negative 8 on the right. On the left hand side, 5c minus 4c is 1c, which we always write as just c, minus 7. Now we're going to undo the minus 7c by adding 8 on both sides. And what do we end up getting? We end up getting that adding 7 on both sides, my bad. We end up getting that c is equal to negative 1. Now, that's one solution. It's a great solution, but it's still one solution, and that's not what the textbook wants. The textbook wants no solutions. So let's take and try the next equation, which is equation C, which says 10 times the difference of p and 1/2 is equal to 5 times the difference of p and 2. Now once again, we're going to start off using our distributive property. 10 times p is going to give me 10p minus 10 times 1/2. Well, that's half of 10, which is going to be 5, is equal to 5 times p is 5p. 5 times a negative 2, that's going to be a minus 10. Next thing I'm going to end up doing is subtracting the 5p's from both sides. And in doing that, those zeroed out, which is going to leave me with 10p minus 5p is 5p minus 5 is equal to a negative 10. Next, we're going to add this 5 to both sides. Plus 5 plus 5. Those are going to zero each other out, which is going to leave me with 5p is equal to negative 10 plus 5. That's going to be a negative 5. And finally, we're going to divide by 5 on both sides. And when I do that, I get 1 is equal to a negative 1. Once again, that is a single solution, so that one can't be it either. So we have eliminated the first 3 equations. That kind of means it has to be D, but let's take a minute and prove why. So we're going to write D, which is 2 times the sum of 3x and 5 is equal to 5 times the difference of 2x and 5 minus 4x. We're going to use our distributive property. 2 times 3x is 6x. 2 times 5 is 10 is equal to 5 times 2x is 10x. 5 times a negative 5, that's going to end up becoming a negative 25 minus 4x. Now we're going to take and combine our like terms. 6x plus 10 we're going to leave alone. On the right hand side, I have a 10x minus a 4x. That's going to leave me a 6x right there, and that minus 25 comes down. Do you see where our issue is going to be now? This is what's going to happen. I'm going to take and subtract 6x from both sides, just like that. And when I do, these zero out, leaving a positive 10 equals these zero out, leaving a negative 25. Now I'm asking you, does positive 10 equal negative 25? I don't think so. And there is our mathematical proof that D is going to be the only correct answer. Now the next part of our lesson wants us to learn to analyze equations to determine the number of solutions. And I've actually been teaching you this along the way. So for example, with no solution, you can see right here, you've got a 6x on both sides that would subtract each other out. And when it does, it's going to leave you with a plus 3 and a plus 1. Does plus 3 equal plus 1? No. So that would end up meaning that that one's going to have no solutions. Now from here we're going to say the coefficients. Are the coefficients going to be the same? You can see you have a coefficient of 6 and a coefficient of 6. Remember, the coefficient's a number in front of your x term. Yes, they are the same. And then are the constants different? The constant is 3. The constant is 1. The constants are different. That means that you're going to end up having no solutions if you have those two things happening. Over here, I've got the coefficients are different. you can see, is the first thing we got going on here, because you have a coefficient of 6 and a coefficient of 4, and you have the fact that the constants, it just really doesn't matter. The constant can be the same or the constant can be different. If your coefficients are different, though, you're going to have one solution. All that matters in this one is the coefficient. Now, to have no solutions, to have infinite solutions, you've got to have both. You have to have the exact same coefficient, 6 and 6, and the exact same constant, 3 and 3. And when you have that situation going on, then you know you have an identity. It's going to have an infinite number of solutions in it. Now, with that newfound knowledge, the textbook wants us to identify what would we need to put in for those two question marks so that that expression or that equation would have an infinite number of solutions. The first thing we're going to have to do is we're going to have to combine our like terms there on the left-hand side. And hopefully the textbook will catch up here in a second. There we go. So you can see they have 6x minus x, that's going to give them 5x, and 5x plus 2x, that gives them 7x right here. From there, the plus 4, it's the only constant there, it's going to come down. So how many x's do you need on this side to have infinite solutions? You got to have the same number, which is going to be 7. How many constants are you going to need? You're going to need 4. So our answer is going to be 7x plus 4. It has to be identical on both sides in order for you to have an infinite number of solutions. Now you take a minute, solve this problem. Find out what you need to put in here so that you will have an infinite number of solutions. Did you do it? I hope you did, because you learn through doing. And now I'm going to do. So first thing I'm saying is 4 times x, that's going to give me 4x. 4 times 2, that's going to give me 8, and the minus 3 comes down. From there, I'm going to say the 4x, it's the only x thing I've got, and my other like terms and my constants, 8 minus 3, that's going to leave me with 5. So I need 4 x's plus 5 1's in order to have an infinite number of solutions. Plug that in, 4 x's and 5 1's, check. The answer checks. It really is that easy to do these things if you know how the rules work. Now in example 4, they want us to do something different. They want us to come up with something so that we would have no solution. And remember, for no solution, your coefficient has to be the same, but your constant has to be different. So how are they going to go about doing this one? Well, pretty much the same exact way. You still have to simplify everything that is on that one side of the equal sign. So we're going to take the 3 right here, do 3 times 2x, that's going to end up giving us 6x. 3 times 4, that's going to end up giving us 12. Next, we're going to say 6x minus 1x is going to give us 5x, and then that plus 12 comes down. From there, as I said before, in order for there to be no solutions, the coefficient has to be the same. So we're going to take that coefficient. It has to be a 5x. And you should have an x right here, but who knows where that x went to. And then the constant has to be something other than 12, because if it's the same and the same, you have an infinite number of solutions. But by having something other than 12, like maybe 8, now you have an answer which is going to give you no solutions to that problem. And it is time for our final example for you to work extra example 4. Pause the video and work on this one on your own. How'd you do? Well, when I'm doing this one, first thing I'm going to do is see if there's anything that has to be distributed, and there's not. Since I don't have to distribute anything, now I'm going to work on combining those like terms. So I can rearrange it to where I have a negative 5x minus 3x plus 2 plus 6. The negative 5x minus 3x, that's going to give me a negative 8x plus 2 plus 6. That's going to give me a positive 8. Now remember, we're looking for no solution here. So to find something with no solution, that means that this value here must be the same. It must be the -8. However, this value here cannot be 8. It can be any other number it wants to be, but it can't be 8. So let's jump back over to the textbook and see what options they give us. First off, that one had to be 8. I'm sorry, that one had to be a -8. And this one can be anything but 8. That means for the choices they gave us, it has to be 12. Check the answer checks, and now it is time to do your homework. Make sure as you're doing this, you're giving me good quality Big Kid supporting work so I can give you a good quality Big Kid grade.